Imagine for a moment you're in a completely silent library, not a single sound. Now, imagine that, suddenly, you discover this library isn't actually silent. It's filled with music, a cosmic symphony playing all the time, but you simply didn't have the right ears to hear it. Well, cosmic explorers, that's exactly what happened with humanity and the universe. For over 400 years, ever since Galileo pointed his telescope at the sky, we could only see the cosmos. But in 2015, something extraordinary happened. For the first time in history, we managed to hear the universe. And what we heard was absolutely revolutionary. Today we're embarking on a fascinating journey to discover how gravitational waves are literally allowing us to listen to the cosmos, revealing secrets that light could never tell us. We'll understand what this mysterious cosmic gravitational wave background is, and how it might be the key to unraveling the first moments after the Big Bang. Get ready to discover how we are living a new era of astronomy, where we not only observe the universe, but also listen to it. Welcome to Cosmic Frontiers, Cosmic Explorers. We're on an incredible journey towards 1,000 subscribers, unraveling the deepest mysteries of the universe together. To understand how we can hear the universe, first we need to comprehend what these mysterious gravitational waves are. Imagine you're in a calm swimming pool. When you throw a stone into the water, waves spread out in circles across the surface. Now, imagine that space and time themselves function like this pool, but in 3 dimensions. When extremely violent cosmic events happen, like the collision of 2 black holes, they literally make the fabric of space-time ripple, creating waves that propagate throughout the entire universe. These gravitational waves were predicted by Albert Einstein in 1915 as part of his theory of general relativity. Einstein realized that mass and energy curve space-time, and when massive objects accelerate unsymmetrically, they create ripples in this cosmic fabric. It's as if the universe itself were a gigantic drum, and cataclysmic events were the drumsticks playing its surface. But here's the most fascinating part. These waves are incredibly subtle. When a gravitational wave passes through Earth, it stretches and compresses space by a proportion less than 1,000th the size of a proton. To put that into perspective, it's like trying to detect a change the size of a single hair in the distance to the nearest star. Seems impossible, doesn't it? That's exactly why it took 100 years from Einstein's prediction until we managed to detect these waves. The breakthrough came with LIGO, the Laser Interferometer Gravitational Wave Observatory. Imagine 2 gigantic tunnels, each 4 kilometers long, arranged in an L shape. Laser beams travel through these tunnels and meet in the center. When a gravitational wave passes, it microscopically alters the length of these tunnels, changing the interference pattern of the lasers. It's engineering so precise that it can detect changes smaller than 1/10,000th the size of a proton. On September 14, 2015 at Shonwu-Wuden-Wushi-Yifan, Time LIGO detected something extraordinary. For a fraction of a second, the detectors registered a signal that forever changed our understanding of the universe. It was the gravitational signature of 2 black holes, each about 30 times the mass of the Sun, spiraling towards each other at near light speed, until they finally collided and merged. This event happened 1.3 billion years ago in a distant galaxy. During the final moments of the collision, these black holes converted 3 entire solar masses into pure energy in the form of gravitational waves. To put that into perspective, for a fraction of a second, this collision released more energy in the form of gravitational waves than all the stars in the observable universe combined emit in light. Now, here's where the story gets even more fascinating. Since 2015, we've detected dozens of these cosmic collisions. Each detection is like hearing a different musical note in the symphony of the universe. Black hole collisions produce low frequencies, like the bass notes of a cosmic double bass. Neutron star collisions, on the other hand, generate higher frequencies, like the treble notes of a universal violin. But there's something even more extraordinary waiting to be discovered: the cosmic gravitational wave background. Just as there's a cosmic background radiation that we can detect with microwave telescopes, scientists believe there's a constant background of gravitational waves permeating the entire universe. Think of it like the background noise of a city. If you stand on a busy street corner, you'll hear individual cars passing, people talking, maybe a siren in the distance. But beneath all these specific sounds, there's a constant murmur of the city as a whole. The cosmic gravitational wave background would be like that murmur, but for the entire universe. This background would be composed of gravitational waves from countless sources, millions of binary black hole systems scattered throughout the cosmos, collisions that happened billions of years ago, and perhaps even echoes of the Big Bang itself. Imagine being able to literally hear the first moments of the universe when it was only a fraction of a second old. Here's what makes this revolutionary. The light we see from the cosmic background radiation was emitted when the universe was 380,000 years old, when it finally cooled enough for the first atoms to form and light to travel freely. But gravitational waves could have been generated much earlier than that, perhaps in the first moments after the Big Bang. Detecting this gravitational background would be like having a window into the first instance of creation. Scientists are using an ingenious approach to detect this cosmic background. They analyze data from multiple gravitational wave detectors around the world, looking for subtle correlations that would indicate the presence of this constant background signal. It's like trying to hear a whispered conversation at a noisy party, but using multiple microphones to filter out the noise. Recently, scientific collaborations like the pulsar timing array have used an even more creative approach. They observe pulsars, which are neutron stars that spin rapidly and emit beams of radiation like cosmic lighthouses. These pulsars are incredibly precise natural clocks. When low-frequency gravitational waves pass between us and these pulsars, they subtly alter the arrival time of the pulses. It's like using the entire universe as a gigantic detector. In 2023, several collaborations announced preliminary evidence of what might be this cosmic gravitational wave background. If confirmed, it would be a discovery as revolutionary as the detection of the first gravitational waves in 2015. We would literally be hearing the background symphony of the cosmos. But what does this mean for our understanding of the universe? First, it would give us information about the population of supermassive black holes in the early universe. These cosmic giants, millions or billions of times more massive than our Sun, grew surprisingly fast in the first billions of years of the universe. The gravitational background could tell us how that happened. Second, it could reveal physics beyond our current knowledge. Perhaps there are types of matter or energy that we can only detect through gravitational waves. Or perhaps space-time itself has properties that we don't yet fully comprehend. Third, and perhaps most exciting, it could give us clues about what happened in the very first moments after the Big Bang. Theories like cosmic inflation, which proposes that the universe underwent an exponential expansion in its initial instance, could have left gravitational signatures that are still reverberating through the cosmos. Think of the magnitude of this. We are developing the ability to hear echoes of events that happened when the universe was less than a second old. It's as if we were cosmic archaeologists, excavating not through layers of Earth, but through layers of time, using waves and space-time itself as our tools. Gravitational wave astronomy is also allowing us to study objects that are completely invisible to light. Black holes, by definition, do not emit light, but when they collide, they scream their existence through gravitational waves. We have already discovered entire populations of black holes that we never knew existed, some with masses that defy our theories about how these objects form, and we are just at the beginning. Next-generation detectors, like the Einstein telescope in Europe and the Cosmic Explorer in the United States, will be 1,000 times more sensitive than current ones. They will be able to detect gravitational waves from collisions that happened when the universe was only a fraction of its current age. Even more exciting, we are planning detectors in space. The LISA mission, from the European Space Agency, will place 3 satellites in solar orbit, separated by millions of kilometers, creating a gravitational wave detector the size of the solar system. This will allow us to detect very low-frequency waves, impossible to detect on Earth due to seismic vibrations. Imagine the discoveries that await us. Perhaps we will detect gravitational waves from cosmic strings, hypothetical structures that could be remnants of the Big Bang. Or perhaps we will discover that primordial black holes, formed in the first moments of the universe, are more common than we thought. We might even detect signatures of extra dimensions of space-time, if they truly exist. Gravitational wave astronomy is giving us a new language to converse with the universe. For thousands of years, our only way to study the cosmos was through light and other electromagnetic radiation. Now, we are learning to hear the vibrations of space-time itself. It's important to remember that we are living a historical moment. Future generations will look back at this era as the period when humanity developed a new cosmic sense. Just as Galileo revolutionized our understanding of the universe by pointing a telescope at the sky, we are revolutionizing our understanding by learning to hear the waves of space-time. Every detection of gravitational waves is like receiving a message from cosmic events that happened billions of years ago. These waves traveled through the universe, passing through galaxies, stars, and planets, carrying precious information about the most violent and energetic events in the cosmos. And now, finally, we have the ears to hear them. So, cosmic explorers, recapping our journey today, we discovered that gravitational waves are ripples in the very fabric of space-time, created by the most cataclysmic events in the universe. We learned that incredibly sensitive detectors like LIGO finally allowed us to hear these cosmic symphonies, and we saw that the cosmic gravitational wave background can be our window into the first moments after the Big Bang, revealing secrets that light could never tell us. When I look at the night sky now, I don't just think about the light from the stars reaching my eyes. I also think about the invisible gravitational waves passing through my body every second, carrying stories of cosmic collisions that happened in distant galaxies billions of years ago. We are literally immersed in a constant gravitational symphony, and only recently have we learned to hear it. This makes me reflect on how many other aspects of the universe are still waiting to be discovered. What other cosmic senses will we develop? What other languages is the universe speaking that we haven't yet learned to comprehend? The journey of scientific discovery reminds us that there are always more mysteries waiting beyond the horizon of our current knowledge. Cosmic explorers, which aspects of gravitational wave astronomy sparked your curiosity the most? Do you think one day we might detect gravitational waves from advanced civilizations manipulating black holes? Leave your reflections in the comments. I love reading your perspectives on these cosmic mysteries. And speaking of mysteries, what phenomenon of the universe do you want me to talk about in the next video? Wormholes, dark matter, the ultimate fate of the universe. Leave your suggestions in the comments. We're on an incredible journey towards 1,000 cosmic explorers. If this video expanded your perception of how we can study the universe, join our crew by clicking subscribe. Like this video if it sparked your curiosity about the gravitational symphonies of the cosmos, and share it with someone who also marvels at the mysteries of the universe. In the next video, we'll explore another fascinating phenomenon that is revolutionizing our understanding of the cosmos. Until then, keep looking at the stars and, now, listening to the waves of space-time.